discussion, just to be consistent, right? So here, 8 and 10 were the same kind of problem. And what you want to do is compare the z-scores, because for 8, you got two different populations. Babies that are born in the 32 to 35 week interval, in other words, less than 9 months, are going to be a different population. In other words, they'll have different characteristics than babies that are born, where's the other one? Yeah, after 40 weeks, which would be 9 months or later. Okay, so I got a couple people coming in all at once, so give me a second, y'all. All right, so, you know, people might call these earlier babies primo babies, and these later babies might be regular, I guess just it's normal, but anyway. So these two things have different characteristics. So how do we compare a baby in a 34-week, which would be the first population and has 3,000 grams, to a baby in the second population, a normal baby, of 3,900 grams? Well, it appears the normal baby is going to weigh more, and the primo baby is going to weigh less. That's what it appears. But these are different populations, so we can't just compare the raw numbers, so we'd use the z-scores, right? And the same thing down here, this would be comparing the height of men and women. So men and women are two different populations, even though they're both human beings, they have different characteristics. All right, so if you look at this, it looks like the man is taller, right? But relative to their own population. So this woman might be taller than most women, whereas this man might be kind of average. So you have to compare these numbers to the mean and the standard deviation. So that's what I'm doing here. And so I labeled X the data value. So X for the 34-week baby and X for the 40-week baby. So you subtract the data value minus the mean, divide by the standard deviation. And if you notice, 0.842 is farther away from 0. So on a number line, it would be right here. So the normal baby weighs relatively more compared to its own population than the primo baby, which is around 0.6. And so these z-scores are kind of used to kind of gauge. So if you get a z-score close to 0, that's kind of average. All right, and then for 10, I did the same thing. So notice the X male, the X females. Okay, so you divide, subtract from the mean, divide by the standard deviation. Okay, and you notice for the female, 0.80 is farther away from 0 than 0.592. So on a number line, it would be farther away from 0, right? And so what does that mean? Well, since this is negative, that means less than the mean. And since this is farther away from 0 than the male number, that means the female is less taller relative to her population than the male. That's what that means. So this 62-inch female is less taller relative to her own population than the male is, and we get that by analyzing the z-scores. Okay, and these are kind of similar if you notice. They 0.8, 0.0, 0.8, one's negative, one's positive. Okay. All right, so then we had these two problems, and then finishing up with a stem and leaf plot and then a box of whiskers of these two pieces of data. Okay. All right, well, so here, basically what you want to do is take the mean and the standard deviation and then create your intervals. And so that's what I'm doing here. So here's the mean, 360.25, and then I just added 30 going up, and I subtracted 30 going down. All right. So when they asked the question for part A, they asked you what percentage for part A here. Well, 95% of kidneys, that would be 2 standard deviations. And so notice, that's why I wrote 2 standard deviations here. So that would be in between 265 and 385. And then they asked you for part B, what percentage would be in between these two numbers? Well, those just happen to be the two numbers in the 3 standard deviation interval. So that would be 99.7%. And then anything outside this interval would be the other 0.3%. Now, part D was a little tricky because you kind of had to intuit what's up. So they asked you in between these two numbers. And if you notice those two numbers, the 295 is half of a 1 standard deviation interval because it's only the lower half. And the 385 is half of a 2 standard deviation interval because it's only the upper half. And so that's why I wrote this down here. All right, so half of 1 standard deviation, half of 68, half of 2 standard deviations, half of 95. And then that's how you get 81.5%. And the same thing with 42. 42 was a little tricky at the end, okay, because you kind of had to know how to get the percentage in between these two, okay? And so, well, if you found the percent to 4.00414, that would be half of 95, which is why I put 47.5 up here. And if you found the percent for half of 1 standard deviation interval, that would be half of 68, so that's why I put 34 here. And so that's what we want to find in between these two numbers. Okay, well, if there's 47.5% between 4 and 4.014, we don't want to count the numbers in between 4 and 4.007. So that's why we take away the 34%, because we only want the percentage between these two. So you basically subtract these two numbers, is how that works. Okay, and then we got to this. This is just doing stem and leaf and then box and whiskers. So what I did notice, I made 2 columns. So in the first column here, I just put the numbers down. And then in the second column, if I had to reorder them, that's what I did. So I only had to reorder these two. And the same thing here. So if you're wondering what that is, I just reordered the numbers after I put the numbers down. Okay, both had 15. And so then 15 plus 1 divided by 2, 15 plus 1 divided by 4, or you could just do divide by 2, divide by 2. So the 8th number from the lower end was 27. The 8th number from the bottom, oh, sorry, the 4th number, my bad. The 4th number from the top, or the larger numbers, would be 23, and then the 8th number was 23. And the same thing here. That's why I circled those numbers. So again, when you do the lower quartile, you count from the lower end. So you're counting starting with 160. When you do the upper quartile, you count from the upper end, so you're starting to count from 326. And then the median, it doesn't matter, because if you count from the lower end or the upper end, you should still find the same middle. Right, and here's your box and whiskers. And if you noted, the data for car 2 appears to be skewed right, whereas for car 1, it's fairly well balanced. And there's a narrow interquartile range. So the distance between these quartiles is much smaller for car 1 than it is for car 2. Remember, that's called the interquartile range. Upper quartile minus lower quartile. Yes, John? Now, when you say, will this be on the test? The problems like 41 and 42, no. Problems like 41 and 42 are not going to be on the assessment. I just think that's a little bit too much for y'all. All right, so you will be getting the Z-score problem. You will be getting the box and whiskers problem. You will be getting the upper and lower quartile problem. Okay, does anybody need to ask anything? It's going to happen very soon, Johns, today. I don't know what you were in class on Thursday. I post stuff on Google Classroom too, y'all, so not just, the video, but also verbal stuff. Okay, well, guys, this is it. This is the last class. And I just want to say it's been really delightful teaching y'all, despite, you know, the end of this semester. But y'all been a good bunch. It's been nice. And as far as what's going to happen next year in August, I really have no idea. I don't even want to speculate. So all I know is that something will happen, right? Does anyone want to ask me anything or say anything? You're welcome, Sophia. Okay, so I'll wait a moment, and then I'll go ahead and leave, and then I'll start sending you all the quizzes. So before I do that, let me make sure I got everybody. I got Sophia Escobar, Mike Lubin, I got Greta, John, Sarah and Samantha Whitkey, Sophia Templin, and then Madison, or Maddie. And did I miss anybody? I don't think I did. All right, y'all. Y'all take it easy. Contact me if you need anything, okay? As soon as I close out, I'll start sending the quizzes. All right, bye, y'all.